Well, if you did not enjoy my last talk, you probably will not enjoy this one either. If you did enjoy it, then maybe this one will be enjoyable too. I don't know. We'll see. I want to shift gears a little bit and not talk about specific practices, but talk about organic as it compares to conventional in terms of the research that we're doing here. And I just wanted to follow up on a comment that Dwayne Beck mentioned earlier today, which has to do with long-term trials. This study is now in its 35th year of being run. And a lot of the information and a lot of the data that we're getting out of this experiment really, I mean, you could never have done it in 2 or 3 years. It just would have been pointless. It's a little bit like if any of you have children, you know, if you did a 2-year study on how children grow, you'd think that they only ever got 2.5 feet tall. And, you know, it just makes no sense at all. You really have to look at things over time. And because the soil is based on biology and it's the way it functions is a biological function as much as chemical and physical, you have to look at it over a period of time to begin to unravel and tell a story. So we're going to talk today for about 40 minutes or so on that story and how we're beginning to try to unravel some of that information. We heard an earlier history lesson this morning, and I'm going to jump on the bandwagon as well, talking about Xenophon. Xenophon said 400 years before the birth of Christ that to be a successful farmer, one must first know the nature of soil. And so often, we just don't pay enough attention to the soil, and our farming systems trial is started out as an experiment to really study the soil. It came on the heels of a USDA report that came out in 1980, where the U.S. Department of Agriculture looked at what was happening in the world of organic. We were nowhere near as successful in terms of consumer sales, and we weren't selling $30 billion worth of product at the time, but it was a growing industry, and we were petitioning Congress and the USDA to begin to look at organic research, and they said, well, let's go out and find out what farmers are thinking. So they did this study and put this report together in 1980 under the leadership of Garth Youngberg. And they began to talk to farmers, and they said, what are some of the barriers to adoption? If some of the things are true that Jeff Moyer and Rodale are saying, if it's true, then why aren't more people transitioning to organic? Obviously, there's got to be some barriers to adoption. What are those barriers, and how do we overcome them? And one of the first things that they identified as an issue was a concern over nitrogen fertilizer. Conventional farmers were saying to them at the time that in order to be an organic farmer, you had to have livestock because you needed manure to be an organic farmer. They obviously did not pay attention in junior high chemistry to understand that 78% of the air that we breathe is nitrogen. They missed that day in class. So they thought nitrogen had to come from an animal, so if you didn't want to have animals, you couldn't be organic. That was kind of the thought process that farmers were telling them. And the other thing that came out of that report was this idea that we needed some long-term trials and we needed some comparison studies. And so Rodale decided in 1981 to take a piece of land that at the time we did not own. When we took over this piece of land to put our long-term experiment in, our farm stopped at this tree line right here. So this was all organic and this was conventional. This had been in conventional corn with tillage. I believe it was chisel plowed, but it was in continuous corn for 25 years before we took it over. This field over here is part of the same farmer's land. We rented this, now we own it. This field was in continuous corn. I think it's probably been, well, 35 plus 25, 60 years so far that's been in continuous corn. So we took this piece of land, and you can sort of see that we tilled it, and you can see where some of the roadways are beginning to take shape. We created an experiment there. It's a 12-acre site. Again, started in 1981. And it was really designed to look at the feasibility of transitioning from conventional production to organic. What's going to happen to the soil? What's going to happen to the crops? And if we can determine what's happening, then how do we mitigate any of the problems that might arise so that farmers don't have to go, so that not every individual farmer has to go through the same process and learn on their own. We can learn from our mistakes or from the mistakes of the system so that we can mitigate those problems on the farm. Then we also wanted to show what the potential of organic agriculture was to improve the soil and the water while producing crop yields and net returns that are, at the time we said, hopefully comparable or at least financially rewarding to the system. Because again, if you can't produce crops and you can't make any money, who cares what you're doing to the soil, because someone else will take over and you'll be out of a job. So in 1981, we put this experiment in the field, and we had 3 different cropping systems, and each of those cropping systems was replicated 8 times. One of the problems that farmers identified along with nitrogen was the fact that there wasn't a lot of good scientific data to support organic production. And farmers, just like everybody else, are modern, intelligent people who want to make decisions based on science, not just on somebody's idea of what they think might be a good idea. We need science to support that. So we wanted to have a very rigorous scientific experiment. So we had 8 replications, and there were 3 starting points for each rotation. So even if a rotation had 5 crops in it, because of we were limited by size, we only had 3 crops in every year. But what that does is it magnifies the size of the experiment, because we have every crop in every year. So you really, if it's a 3-year rotation, you got 3 different crops, and you did it for 30 years, we actually have 90 years worth of data. So you kind of can do the math and magnify that. The plot sizes, just so you get an idea how big the plots are. The main plots were 60 foot by 300, and each subplot is 20 feet, so it's an 8-row plot. They're 8-row plots, and we farm them with farm-scale machinery. We don't, if we're baling hay, we actually go out there with a hay baler, and if we're planting corn, we go out there with a corn planter, albeit it's only a 4-row corn planter, but farmers can get the idea and do the math in their head and see whether or not something works with them. And then in 1990, we also buried 60 lysimeters in there, so we have a lot of water data. I think we have right now, they're telling me about 45,000 data points on water collection alone. If you look at those 3 systems, just so you can kind of figure out where your farm might fit into this or where your thought process is going, the 3 different systems were, one was based on animals, because we said, okay, let's say farmers are right. We do want to have animals in our rotation, and I would agree that if you're an organic farm and you have animals on your farm, life gets a lot easier. Your crop rotations can be more diverse, your income stream can be more diverse, and your ability to manage the health of the soil, it can become easier. So we have a system there that has animals and that has manure as its primary source of nitrogen. But then we have an organic system that's based on legumes, so that system never sees animal manure. Even though theoretically manure could be available because we have it in the other plots, those plots never get any animal manure. They never get any sort of synthetic or manufactured nitrogen. The nitrogen all has to come from the cover crop that we plant. No substitution there. And then we have a conventional system that's based on using synthetic nitrogen. Then in 2008, we split those 8 plot reps into 4 reps. 4 reps is enough for science. You don't need 8. And we really wanted to take a look at this tillage piece. So in 2008, we divided each of these systems in half. So now there's 4 reps of organic manure with tillage and 4 without tillage. Same with legumes, same with the conventional. Because we could look at conventional ag and say conventional agriculture has changed from 1981 to 2008, and more people are no-tilling, and we need to keep this experiment modern so that conventional really represents conventional. The other thing that we did was the conventional no-till system moved to GMO crops. And I will tell you, that was a big decision for our board of directors, who was very organic-minded, to say Rodale's going to be planting GMO crops on land that they own. But that's what we do in those particular treatments. And if you look at what a map of those plots look like, you get a feel for what it looks like. You can sort of almost picture that picture that I showed you with the tilled soil and where those roadways were starting to take shape. Here's those roadways, and here's all the plots, and they're beautifully color coordinated. And you know, every time we go to the field, You have to take a map with you because it's like a program for the baseball game. You can't tell the players without a program. You get lost out there, and pretty soon you're doing something wrong in the wrong plot. And in a long-term study where you've got millions of dollars invested, scientists get very upset when you do that. We have a new farm manager just started last year. He made a mistake this year. We told him that he only gets one mistake in his whole career, and he just made it, so put some pressure there. If you can read this in the back of the room, you've got much better eyes than me, and it's really not important. This one. I just wanted to show you that so far we have 46 peer-reviewed journal articles that have come out of there, either for people's PhD thesis or work that's been done by other PhDs that are just working on their projects. So again, this idea that there's good science behind what we're talking about. This isn't Rodale telling a story. This isn't the organic industry putting information out there on what they think. It has nothing to do with what we think. It has to do with what science supports. The other thing that you can't read, but you would notice, is that almost every one of these papers was not written by a Rodale scientist. They were written by partners who we've worked with over the decades that have come in, superimpose experiments onto our plots, using that area, that soil area, as a research lab. So if any of you are research scientists and you want to do work on our plots, we invite you to come and work with us. You have to bring some money, but you're welcome to come. So we have people, again, that work in just about every land-grant university in the country and the USDA. There may even be somebody there from Guelph. I know we did some work with some folks from Ontario. So they might be in that list. I can't read it any better than you can. Just give you the idea that there's peer-reviewed journal article science behind it. So if you don't like our science, you can't really like anybody's science because it's there. There are some primary differences in this experiment beyond just the nitrogen source. Obviously, there's a different set of crops, so crop diversity is different. The amount of living ground cover is different. That plays a huge role in the data that I'm going to show you. We already mentioned the type of nitrogen fertilizer, and of course, the weed management strategies are different. The conventional is going to be based on synthetic herbicides. The organic system with tillage is going to be based on cultivation, and the organic no-till system is going to be based on cover crops. The conventional-based system just kind of goes over that again, reiterating what I talked about, that the tilled system is a chisel plow system. The no-till system is just that. It's continuous no-till. We don't do anything in there, no zone tillage, no nothing. It's just straight no-till, and we depend completely on chemicals for our weed management and also for our fertilizer. In the tilled system, it's a mixture of tillage and chemicals for weed management or weed control in that system. The organically, the legume-based system has some different crops in it. You can see we have corn and soybeans, just like in the conventional, but we also have wheat, oats, and barley in there. And then we have cover crops of winter rye and some legumes. And the nitrogen source is completely hairy vetch and clover. Those are the complete source for nitrogen there. And in the animal system, again, much more diverse because we have use for corn silage, we have use for hay, so we can add those crops in there. Starts to stretch out our rotation. Anybody ever plow sod and plant corn? If you've ever plowed sod and plant corn, weeds are like a non-issue. I don't care if you're conventional or organic. Weeds just aren't an issue. So as a farmer, I would be amiss, as an organic farmer, I'd be amiss if I didn't take advantage of that piece of information and say, oh, maybe I should try to get sod in my rotation now and then so when I come out of sod, I'm managing my weeds differently. And we do that here. The other thing that we're looking at in this experiment is, of course, we're looking at yields, but not just yields. Yield is a relatively poor indicator of your job as a farmer. That's shocking to most people. And you talk to farmers and they go, oh, I have to yield more than my neighbor, you know. It's like, why? How many people here get to take corn to the bank? You don't show up with a tractor trailer at the bank and go, here it is. You got to show up with dollars, just like everybody else. So our goal is to generate dollars. Now, yield plays into that, of course. We do need yield to make it work, but not just yield at any cost. I have a neighbor, he likes to tinker on diesel engines a lot, and he has a tractor that was rated at a 110 horsepower tractor, and he was putting 160 horsepower out of it. but his fuel consumption went from 5 gallons an hour to 9 gallons an hour. So he paid, he doubled his fuel consumption and only got, what, 30% more horsepower. The curve starts to go downhill. I don't want to be on the downhill side of the curve. I want to be up at the peak of the curve where I'm maximizing my resources in terms of my income, not my yield. But we're also looking at the health of the soil. Because as we heard today, earlier this morning, if all we do is think about short-term yields, we're going to be in a big bind 50 years from now. And we're all going to be saying, oops. And I have our executive director, who's my boss, often tells this story, and he says, at the end of everything, when we're done farming, you're going to have to look at your grandkids, and your grandkids are going to ask you a question, and there's 2 answers. And the question is, Grandpa, when all this was happening, were you part of that? And the one answer is, you hang your head and you go, yeah, I was part of it, and we got it wrong, and I'm sorry for the mess we left you. The other answer is, yes, we were part of that, and we solved the problem, we created healthy soil, and now we've left you with the abundance that you have. And that's really our choice and how we manage those resources, and it's that serious in terms of the impact that it's going to have. So we look at soil health, and we take that to heart when we're looking at these projects. We also look at water quality. We're looking at an energy analysis, because yes, gasoline's fairly reasonable right now, but anybody who thinks energy is going to remain cheap for the next 50 years is probably not on top of their game. And of course, we have to look at the economics, as I just mentioned. It's not just about yield. Yield's interesting, but really it's all about dollars. We do have different crop options, and I'm going to show you some slides that are, again, are a bit of an eye chart, and I apologize for that, but it's just no good way to depict these diverse rotations without actually putting them in a chart like this. And all I want to do is show you that the rotations have changed over time. This is what the rotations look like from 1981 to 2002, and the manure-based system really didn't change much over that time period. I don't know what happened there. Oh, there it is. The legume-based system changed quite a bit because we were playing with it. We didn't understand, we were trying to maximize the nitrogen, and we started out, everybody said, oh, plant red clover. So we did, we planted red clover. But red clover didn't give us enough nitrogen to grow a decent crop of corn, so this is where we're in that learning curve, and we want to take advantage of that learning so that you don't have to, and why keep doing the same thing if it's failing? So we switched to a hairy vetch cover crop, and the system got much better. The conventional system for those 20 years pretty much stayed the same. Corn, soybeans, corn, corn, soybeans, and that's the way it went. From 2004 to 2007, the system changed again. And what we did was, in the conventional system, we added wheat. We have since taken wheat out of that rotation because it really didn't make sense, and it was confusing the data. So we took wheat out of that rotation with the idea that as farmers, you can hybridize the system and put wheat into the rotation. You can put any crop you want in there to maximize the potential of it. But the wheat wasn't really working out well, and it was driving the economics of that system in the wrong direction, because our goal is to maximize all the systems in terms of the economics, and corn and beans were a much better driver there. From 2008 to 2013, it changed again, because remember, we split the tillage. So now we have 2 different systems. One's tilled, one's no-tilled, tilled and no-tilled, no-tilled and tilled, and we have each of those systems like that. And we got a new scientist in 2014, and so the chart got more confusing. I think that's job security for PhDs. Make the chart really confusing. Anybody here have a PhD except for Dave? I'm not picking on you. I'm just saying. So here we're looking at the first 2 columns are 2013 and 2014, and then she's planned her rotation out for the next, 8 years. You as a farmer, thinking about transitioning to organic, thinking about including cover crops, thinking about possibly changing your system, should build a chart like this. Because if you can't tell me what you plan to put in a field 5 years from now, you're not doing your job. And you're not going to be successful. You need to have a plan, you need to have it written down, and you need to move in a positive direction in that regard. Doesn't mean that your plan is going to be successful or that you're not going to change it. You have to build some flexibility in there, but you definitely need a. Looking at just yields, you'll see that the long-term yields of the system are very similar. Statistically, anywhere there's an A, they're all the same. So these are all pretty much the same yields. What has changed is when we had conventional no-till, and that's because we're comparing, a lot of these things we're comparing a 28-year average to just a 3-year average. So we hit some good years in here for corn, but we also have taken advantage of some better genetics. And we're doing a little bit better in yield. We're not doing better, as you saw in the earlier presentation, in dollars and cents, but we are doing some better in yield. Same thing is true with soybeans. Pretty much uniform in soybeans, no real significant or statistical differences, except when we got to the conventional no-till, and again, that's only 3 years average compared to either 18 or 29 years of the other data. And wheat was pretty much the same too. No real significant differences in wheat, and in those few years, here we had 2 years of wheat, but I said wheat's out of the rotation, because again, it was dragging the economics down, and that's not our goal. So if we look at long-term grain yields, except if we take out the 2 years of data for the no-till here they're all the same for the wheat, pretty much no differences at all. You can see that they're fairly uniform, fairly consistent. And that's even taking into account some of the early years in the organic no-till transition when we went cold turkey. And I was there from the beginning of this experiment, and I can tell you that corn had been in continuous no-till, for continuous corn with chisel plowing for 25 years, and we came in with no cover crop in the organic system that's supposed to have a legume there. There was no legume there, and we planted corn. And the corn germinated and got about knee-high and turned so yellow, and it was like, where's the juice? Well, the juice wasn't coming. And so those yields really drug down those early transition years, but we had to go through that process scientifically to make the system work. What's really interesting is anytime, and this is corn yield data for, it's only looking at 5 years, but it's 5 drought years. Every time there's a drought, the organic system yielded more than the conventional system. Okay, let's think about weather patterns today. There isn't almost a time or a spot in the United States when there isn't, in every growing season, a drought somewhere. They're short-term droughts. 2013 was the wettest year on record in Berks County, Pennsylvania, where our farm is, and yet we had a 7-week drought during the growing season when the corn was pollinating and our yields were down. And then it started to rain, and then it didn't stop raining. It rained all spring and it rained all fall. And so our average rainfall is 42 inches. We had over 65 inches, 70-some inches, like 6 foot of rain in that year, wettest year on record. And we still had a drought during the growing season. So we really have to look at what's happening climatically. Dave was talking about climate change, and it's going to impact how we farm. So how do we drought-proof our soils so that they produce even when the weather's not right? I liken it a little bit to it's like a racehorse. You know, the conventional system with all the inputs is like a thoroughbred racehorse. When the track is right, that horse can run and nothing's going to catch it. That's what it's designed to do. And billions of dollars have been spent on research to make sure that that system works. But when the track gets wet or the track gets dry, and we see that happening more and more often, that horse can't run. The organic systems are a little bit more like an old workhorse. They get up every day and they work, just like you and me. And you can take them to the bank and you can count on a steady yield, even in a drought, or if it gets too wet, they just keep working. Now, as a farmer, thinking about risk, that's a pretty important piece of information. And how we manage that risk on our through managing the soil is really important. Just wanted to show you that this basically is just saying that the yields are comparable from across systems. So using yield and saying, well, we can't farm organically because we can't produce the same yield just isn't true. We have a lot of data that supports that. I will say that after we ran this experiment for about 10, 12 years, the USDA looked at our data, because they're part of our partnership. They looked at our data and said, well, of course, Rodale's doing this experiment. I'm not surprised. Organic looks pretty good. Let's create a research project at the Beltsville Research Station in Maryland. We're going to run it with conventional scientists and conventional-based farm management and see where it comes out. They got the same results we did. The organic system, their yields are exactly the same. University of Wisconsin did their experiment, same thing. Iowa State, same thing. And UC Davis, different crops, of course, they're different. And there's fluctuations in the data. They don't match up perfect. But in general, the organic systems can yield as much as the conventional. Except in drought years or really wet years when the organic actually does better. It's just that the conventional system would do better if the weather would cooperate. If we always had perfect years, that system would do better. I'm going to jump. But I said yield's not the only thing we look at. We're looking at the soil, because the soil is incredibly important, and you saw those pictures there. We'll jump over that. What we're looking at right now is we're looking at soil carbon. Soil carbon and the carbon economy is going to become more and more important as time progresses. We don't know how we're going to get paid for that, but farmers, I think, in the future will be rewarded for sequestering carbon. We just haven't figured out a good system to do it. And what we're seeing is that organic systems sequester more carbon. We're sequestering more carbon, building more soil, building the health of the soil, and improving the organic matter in systems that have tillage even more than conventional systems with no-till. And we're doing that because of the cover crops. If you took cover crops out of the equation, of course, we would be destroying soil. But cover crops are a huge mitigator in that situation, which is why Ratan Lal will tell you that because he was quoted earlier today, he will tell you that if you're not using cover crops in your system along with no-till, you are doing nothing to improve the organic matter of your soil. The very best you can hope to do is maintain what you have. And most farmers in general aren't doing that because none of us can perform at the top of our game every year, all the time. Cover crops are incredibly important no matter what system you're using. And if we can incorporate them in there, we're going to do much, much better. Looking at that carbon data over time, this is what we see. Now, I will say that in the beginning of this experiment, carbon was not one of the data points that we were collecting. So we have a huge gap. We have baseline data because we collect soil samples every year and we archive samples. And so we could go back and look at that. And then we started looking at carbon up in here around 1995. So we went 15 years without looking at carbon. And we saw these changes. And the conventional really hasn't changed much. It pretty much ends up where it started. The legume and the manure system are continuously going up. This would not be a steady straight line. This would be up and down, up and down, up and down. If we had more data points, we just don't have them because it's not a straight line. The other thing that we've been noticing now with Dr. Chris Nichols, she's looking at carbon sequestration at different depths in the soil. Because if we're going to get rewarded in the future for sequestering carbon, we don't want to sequester it at the surface of the soil where it can easily be burned up and placed back into the atmosphere. We want to place it at depths in the soil where it can be stable and stay for a long period of time. And what we're seeing here with this chart is this bottom line is the conventional system. That's 0. And these are the greater depths. All the organic systems are sequestering carbon at much greater depths as we move down through the soil profile. That's what's causing the difference in drought-proofing our soils. There's 2 ways to drought-proof your soil. One is to do it biologically. The other is to do it with crop insurance. In the States, we have crop insurance. So if you lose your crop because of a drought, you just call your insurance agent, and then if you can prove everything, you did everything right, they give you a check. It did not rain more on this side of the field than it did on this side of the field. We're managing water differently, and it's the cover crops that we put into the system that build up the carbon, that change the organic matter content, that help us manage water differently, even with tillage, because this was no-tilled and this was tilled. This probably wasn't no-tilled, that was chisel plowed, I'm sorry. This was chisel plowed, this was moldboard plowed. Another eye chart. For that I apologize, but I didn't know how to take a picture of a soil test. And this is not part of our research plots. This is just a random sample that I pulled off my desk for our farm in general, our research station in general. And just wanted to look at the percent organic matter content over here. And I know it's impossible to read from the back of the room, but what it says is we're ranging anywhere from 6.1 to 7.0 to 4.5 across fields on our farm. When I started at that farm, we were around 1.7 to 2 at the max. We changed the organic matter content of the farm. We're improving, that's just one little measuring stick, but we're looking at how we're improving the health of the soil while we're using the soil to produce crops. As a farm manager, when I got hired there, Bob Rodale told me, because he owned the place, he said, here's the deal. You have to produce crops every year and make your financial budget. If you don't, you get fired. You also have to improve the health of your soil. If all you do is improve the health of the soil and don't market crops, you get fired. If all you do is market crops and don't improve the health of the soil, you get fired. He was big on firing, I think. But the point was, you can do both. As farmers, we can have our cake and eat it too if we do things differently. But we have to change the way we think about things. This is not a soil chart. This is actually a stock market. But what it's trying to depict is, it depends where you measure your soil in terms of soil health. If you measure your soil and you take a soil sample here, where things are on a decline, you're going to go, oh, the health of my soil is going down. But it's the trend line. You got to look at it over time. To Dwayne's point, we have to look at these systems over a long period of time, or you're going to get false information and bad information. If you looked at this over here, you'd say, oh, look, I'm going up, I'm going through the roof. But in reality, you're over here, which is much lower. So you can't, soil samples are just a window in time. It's just a picture of what's happening in your soil, and you don't want to make radical decisions based on one soil test. You take a soil test every 5 years, you can't tell where you are on that chart, going up or down. You have to take soil samples continuously at the same time of the year over a long period of time to see what your trends are. Your decisions as a farmer are making sense. In 2014, we did a paper on climate change from the data that came out of our project there. And again, showing how agriculture can be part of the solution. If we're part of the problem, we have to be part of the solution. If you look at the world meetings on climate change, agriculture is not even at the table. We are discounted and excluded from the conversation because nobody wants to pick on agriculture. The reality is, though, if we're not at the table during the discussions, we can't be part of the solution, and we know to be. Again, we have lysimeters in the field. We're taking a lot of water data, and the water data that we're looking at, in particular, looking at pesticide contamination. And we picked atrazine because we could get funding to look at atrazine, but we could have looked at any number of different things. And what we're seeing is that when well, let me step back and say atrazine use in the United States, that's a map, USDA map, just showing where atrazine is used. And if you can sort of take a mental snapshot of that and keep that in mind, because we're going to go to the next slide, there's where all the wells are that are contaminated with atrazine. Now, when the EPA looked at the earlier maps on atrazine contamination, they saw that a very large percentage of the wells were being contaminated with atrazine at levels higher than their standard. So what do you think they did? Change the standard. Now it's not polluted anymore. Okay, it's one way to deal with the problem. But long term, it's not a solution. So we know we have contamination in our wells, and so looking at what was happening, we're looking at what was happening in our plots, and what we saw was that when atrazine was applied 2 years in a row, atrazine levels in the groundwater was 3 times the level of drinking water standards, even with the new standard. So even though we're applying according to label recommendations, it's no guarantee that we're not going to end up with that material in our drinking water. So again, trying to think of this long-term picture that we're painting for what we're going to leave our children, how we're doing this, using short-term yields as the measuring stick at any cost is probably not the best idea. And of course, recent trends in agriculture in terms of pesticide use is going more towards GMO, more towards Roundup. What did they say? 94% of all soybeans are now Roundup ready, 72% of corn grown in the US is genetically modified. It's the trend that where we're heading, and now we're going to have 2,4-D resistant crops. And is that the path we want to be on? That's the question that we're asking. Energy, more data. Energy is really interesting because, of course, it fluctuates, but what we're seeing is that conventional systems use 45% more energy than the organic systems. So we're actually reducing the amount of energy that's embodied in the system. That's not just the energy that's on farm. That's energy for the entire commodity chain. So we looked at the energy that goes into the production of nitrogen fertilizer, for example, or the energy that goes into creating the Roundup that then gets sprayed on your crops, because that really has to be accounted for in the crop production, versus energy that you apply on the farm, which could be your own labor driving your own tractor. And so when we look at that data, you'll see that there is more diesel fuel used on the farm, on an organic system, than there is in a conventional system. But the beauty of that is that's a commodity that you have some control over in how you use that diesel fuel. You can buy a a more fuel-efficient tractor or something like that. Whereas when it's embodied in the production of mineral fertilizer, that's just something you have to pay for. It comes to your farm, has a price tag, has an energy price tag that you have absolutely no control over. We also have more energy embodied in seed production in the organic system and less in the conventional system. So we moved things around. We have more labor, more energy in labor, slightly more in the organic system. The problem is you can double the amount of labor and it's still a small amount compared to how much energy is embodied in nitrogen fertilizer. Tropicana Orange Juice, who is owned by PepsiCo, did a study where they're looking at the carbon footprint of what it takes to put fresh squeezed orange juice onto the tables of North America, with the idea that they were going to change their packaging, they were going to change their distribution system to try to cut their carbon footprint down. What they found out was 58% of their carbon footprint was in the nitrogen fertilizer that they put on the orange groves. They didn't pay attention in junior high chemistry because the air, you don't have to buy nitrogen. In most cases, if you manage your system properly, and we have orange groves that are now owned by Tropicana that are starting to put cover crops in the field. They're not transitioning to organic. They're saying we can save money and have a better carbon footprint. These energy budgets look very similar to the economic budgets. This one is for corn, and you can see that because of the fertilizer in conventional corn, the energy budget is extremely high, tilled or no tilled. Much higher than the organic systems. And it's all because of the nitrogen fertilizer. And you know, we have to think about that when we look at energy, whether we talked at our table earlier about fracking and wherever the energy is coming from, whether it's international or nationally produced, we have to think about where that's coming from. In the soybeans, there is not as much difference. In fact, over here, the organic system has a higher energy cost than the tilled soybeans. And that's because we're putting more diesel fuel in there for cultivating and for cover crop production. So it's not always a perfect system. But we're also emitting fewer greenhouse gases in the organic system. So it's a double whammy. We're using less energy and we're producing less greenhouse gas, so we're helping mitigate the climate change problems. We have to think about dollars and cents. And of course, we saw a little bit earlier in the corn data, what we're trying to show here is that the organic systems are about 3 to 4 times more profitable. So if you're looking at your farm strictly as a business model, you're coming in off the street as one of those economists that couldn't figure out whether I saved money in corn or not, and you just looked at your farm and said, what's the best way we can look at our farm economically, and you're not looking at organic, you're missing the boat. Because right now, at least, I don't know how long-term or short-term it'll be, but the marketplace is rewarding farmers for transitioning to organic in the price of the products that you are able to sell. Corn in Pennsylvania right now, last time I checked was maybe a month ago, was at $13.90 a bushel. My son had to buy corn a year and a half ago for his dairy herd because we ran short. He paid $18 a bushel for a tractor-trailer load of corn. And you feed it to cows that think it's candy. And they don't stop eating just because it's $18 a bushel, and you stand there and cry because they keep eating and you tell them, slow down, just don't eat so much, but they keep eating it. So if the marketplace is going to reward us for that, why aren't we moving in that direction? I can tell you when I was in Argentina, those folks are looking at the model of what's happening in North America and Europe and saying as consumers are shifting towards a preference, particularly in chicken and meat products, they need grains to feed those animals, and if the US and Canadian farmers aren't going to produce it, they are, because they're strictly looking at numbers and saying what can I do with those numbers. In fact, the one farm that I was on, they said they're making so much money selling organic crops into the US that they're starting to buy farmland in the US because they don't know what to do with their dollars, and so they're actually buying up farmland in the United States. So we know we can make more money. In fact, if you look at the data over the entire run of the experiment, what we're seeing is that our income is higher, our expenses are lower, because we've internalized those expenses. So even though there's expenses, a lot of them are internalized, so we have control over. If you're paying for your own labor, you know, that's money that you get to keep. If you're paying somebody else for their labor, then that's money they take off your farm. So our expenses are less, and ultimately our net returns are just about 3 times as much, which is huge. I mean, it's not like it's close. It's like it's really far apart. So even if, I mean, we're thinking back to yield, even if our yield wasn't as good as it is, we'd still be making more money. But our yields are good, and there's no excuse to take a back seat. Just another way of looking at that economic data and where those dollars are being spent and where you get to keep them. And the nice thing about that is here you can see that we have more money in labor. And what is labor? That's your salary. We want to pay ourselves. We saw this production budget on corn, similar on soybeans. I'm running short on time. Wanted to talk a little bit about weeds and weed pressure. We do have weeds in some of our organic systems. Nobody wants their field to look like this. I think that's a soybean field. What's causing that problem? We need to start to do more work on that because we can't accept that kind of weed. In that particular case, in those plots, this is kind of interesting to me. In 1997, we hired a new research manager for our farming systems trial, and she said, "You're tilling the soil too much." I agreed. I said, "But I don't know what to do about it." She said, "Well, we're going to switch, in the organic plots, we're going to switch from moldboard plow to a chisel plow." The field crew liked it. They didn't even have to drive straight anymore, and they could drive through there with a chisel plow. And so we went in there with a chisel plow, and there's our weeds, our weed pressure. We were going along a fairly steady state with weeds across here. In 1997, we put in the chisel plow. Look at my weed pressure in the organic systems. Went through the roof. I'm still paying for that way out here in 2014, finally getting back down to where it belongs. The way we manage the soil has a huge impact on the weeds that are killed. The other thing that we noticed was, and it's hard to say this because I don't like weeds any more than anybody else, but the idea of annihilating weeds and getting them out of the system completely is probably not practical, both in terms of how much it costs and also in terms of yield. What we were able to see is that you saw the yield data, and the yield data took place even when we had 5 times as many weeds in the field. We still had equal yields in soybeans. To look at some variety studies. So we went out of those plots and we started looking at varieties and their impact and the reflection of weed pressure on different varieties. No seed dealer will ever give you this information because they don't have it. But we were looking at growing human consumable soybeans, and these variety numbers, this is 10-year-old data, so they probably don't exist anymore, and that's okay. In fact, NC Plus is now Blue River Seed. They don't even exist as a company. And what happened was when we planted these seeds in the field, these are soybean seeds, they were replicated, randomized, and then we actually planted weeds, and then we hand-weeded plots, because this is science, and that's what scientists like to do. And they went out there and hand-weeded the plots, and the idea was to see which soybean varieties are willing to fight for water and nutrients. When weeds were present, this soybean variety, the most we could make it lose was 7% of its yield potential. This soybean variety, as soon as weeds were present, it lost 50% of its yield potential. So as an organic farmer, that's telling me this is the one I want to plant. Because just by checking a different box on the order form, I risk cutting my yield in half, just by picking a different variety. Same thing was true with corn. We looked at corn varieties, and when corn breeders look at varieties, they don't look at their response to weed pressure. But as farmers, whether you're conventional or organic, we have weed pressure. Organic farmers may have more or different weed pressure, and they have to cultivate, I understand that. But how do we begin to look at these things? Do we have to do all that research on our own farms, or can we do it at a place? In summary, what we're saying is that over 30, 35 years, we have the same yield. We use less energy to get that same yield. We emit fewer greenhouse gases to get that yield, and we make more money while we're doing it. So no matter which measuring stick you use, organic systems come out looking better. The system is dynamic. It needs to change. In 2015, we're doing things a little bit different. We're going to try to exploit the characteristics of each system. We want, as a farm, we want every system to perform at its maximum. That's our goal. We're not trying to shortchange any one system for the love affair of another. We want them all to work out well and then let the data fall out where it does. And so we're changing that. We're going to look more closely at the soil microbiology of what's happening in these systems. We have a soil microbiologist on staff, Dr. Nichols, and she'll be looking at that. And then the other thing we want to start looking at is the nutrient density of the crops that we're producing, even though they're agronomic crops, and we don't eat them, of course. We have field days. We invite you all to come out to Rodale, get a busload of folks from Ontario. We'd love to have you come out and look at our field days and see what we're doing. And I'm just going to leave you with this comment here from Wendell Berry, who said, we started with Zeophon, we'll end with Wendell Berry. The soil is the great connector of our lives, the source and the destination. That's all. Thank you.
Jeff, we probably will not have time for questions now.